We can use .m function files in MATLAB to write our own functions. This empowers us to extend our code beyond MATLAB's native functions and target our work to specialized projects that we might be working on. Once we've written our .m function files for a specific project, we can reuse that code in any other context and call it just like a native function in MATLAB. From that standpoint, we can think about function files in the same way we think about MATLAB script files. It's segments of code that allow us to break large projects into small development and iterate over time. Just like script files, function files have a special syntax that we're going to follow every time that we use them. Let's take a look at that syntax. When we define a function file, the file will always start with the keyword function. So the first word that we write is function. We'll always end a particular function with the keyword end. So we start with the word function, we end with the word end. Everything in between is called the function body. Right next to the keyword function, there is specific syntax. First thing we're going to do is use square braces to define the outputs of the function. So here we see square brace out1 means output argument number 1, out2 means output argument number 2, all the way to outn, which is the nth output argument. We close the square brace to say these are the end of the output arguments. Then we have the assignment operator. Right to the right of the assignment operator, we write our function name. We'll talk a lot about kind of wise choices for function names. I'm going to include a capital letter somewhere in this. MATLAB's native functions have all lowercase letters. I like to use a capital to show this is not a native MATLAB function. This is something that I coded myself. Right after the function name, no space, we put an open parentheses, ended with a closed parentheses. In between, we put the input argument. So in1 means input argument 1, in2 input argument 2, all the way to in m, which is input argument m. Notice that the number of input arguments does not have to match the number of output arguments, so we can have different numbers in both of those. After we have that first line, which says this is going to be a function, here's the name of it, this is the number of outputs we're going to have, the number of inputs we're going to have. In between function and end, we said was a function body. The first lines of that function body are going to be documentation. We've talked in previous videos about how to document MATLAB code. We're going to continue to use that. And then we write all executable code in between. As we'll see, it's important to make sure that we use all of the inputs and define all of the outputs somewhere in the function body. MATLAB will actually kind of yell at us if we don't do that. With this syntax in mind, let's work on our first example of implementing a function. Specifically, we will make a function that checks two input vectors and make sure that they have the same number of entries. See what we mean in just a second. To do this, right now I see that my current window is in desktop. I'm going to go ahead and make a directory which is called vectorSizeTest. And that should be now right here. You see that we made the directory. Let's go ahead and change our directory to that location. Okay, now what we're going to do is create a new function file. So I'll go up to the new button, drop down menu, go down to the function file. Notice that MATLAB automatically gives me a syntax, a file, .m file with similar syntax as the one we discussed before. I'm going to go ahead and dock this thing. I guess keep it undocked, it doesn't matter. So in this case, we'll call it vectorSizeTest. This is going to be a function. It's going to take two inputs, which is going to be hopefully two vectors x and y, and it'll produce a vector, a logical scalar output, which we're going to call vectorTest. I want to call out a few things here. Before I look at that, I'm going to go ahead and do one line of documentation. Tests to see if test or checks, I guess, checks that two input vectors have the same number of entries. All right, we're in the development stage. I guess we could do a little bit of work here. And to do that, let's go ahead and use the notation that we had earlier. In this class, we've already seen how to create function files. This was our kind of automated script to do this. let's go ahead and just kind of copy and paste this so we remember what we're doing here. So input 1 is going to be x. This is going to be an input vector. And then input 2 is going to be y. And that's a input vector number 2. So we'll call this number 1. And then the output is going to be a logical scalar, which we call vectorTest. Logical scalar. And we might want to say to indicate if inputs have same number of entries. Logical scalar that indicates inputs have same number. Maybe we'll use this thing, right? Okay, so here we go. I kind of don't like the number of spaces here. This is all part of the process of writing code. So here we go. We say function, output is vectorTest. That's going to be a logical scalar, as we see here. In the name of the function is vectorSizeTest. I've capitalized the S and the T. The moment these are capitalized, I know this is not a native MATLAB function. It's a function that I'm writing myself. My inputs are X and Y, which is kind of nice. And then we want to check if the two vectors have the same number of entries. I did want to call this out real quick. When I do this work, let me save this. We're in the vectorSizeTest project file. Notice that the saved file name has to match exactly the function name that I put here. If I were to change this, if I were to change it, I don't know, maybe like rest, and I do this, MATLAB immediately gets mad about this. Do you see this? The function name vectorSizeTest is known to MATLAB by its function file, but it's different. And so what it will do is fix it. If I fix it though, it will change this to the name that I saved. If I go back here and I save as, I'm going to save this as vectorSizeTest. That's the one I want. Now that I have that, I'm going to go ahead and delete the example there. I don't need that in this project. All right, so here we go. We have this function that's designed to test the size of two vectors. We haven't necessarily assigned the input yet. I'm not ready to do that. One thing that's kind of interesting is that when we're working with functions, it will be useful to test the functionality of functions throughout the development stage. So I like to create a driver to do that, and that's going to be a script file. So let's go back over here. Let's do a new script file. And we'll go ahead and save this thing as vectorSizeTest driver. And so this script file is designed to test the vectorSizeTest.m function. And then each line of code here tests different input cases to make sure that our function properly handles the various types of input that a user might pass to this function. When we give a function input, that's what we do here. So, I don't know why I think I saved the wrong thing here. So vectorSize driver. All right. So the first thing we're going to do is just to make sure that this thing works. So let's go ahead and just set this to true. So this is going to be the least interesting function in the world. So this function literally takes two inputs, and it says that the two inputs are size true no matter what, right? let's go ahead and run this thing. So vectorSizeTest, we'll go back to our driver. We actually have two separate files here, so let's not save this thing. And we'll bring this file over here, which is our driver, and we'll bring our vectorSizeTest function over to the right so we can look back and forth between the two of them. Let's go ahead and set x to be a set of all ones, and we'll say that it's a 10 by 1. And then we'll set y to be what we call the empty column vector. So we'll say that it has 15 rows and 0 columns. And then we'll pass this thing and we'll say that this is the vector test value. Let's go ahead and run this thing. MATLAB. Oh, it says that it's not the 0 function, it's the zeros function. That's of course true. Let's run this thing again. And check that out. We produced a logical 1. This is where we might actually want to dock this so we can actually run between. So let's go ahead and dock this thing. And we will also dock our function file. So let's dock this. So now we've got the two function files. We've got the command window on the bottom. What we've just seen is that the driver function works properly right now. So we're just kind of iterating this. Okay. Remember that the goal of this is to check that two vector have the same size, and we might actually inputs must be non-empty vectors. So why don't we impose the idea that these two inputs must be non-empty, and we can actually check that. So one of the first things that we might want to do in this is actually check that the number of arguments that we have, the number of input arguments, is exactly equal to 2. You can use the help to check narg input. This is a special thing that you can use inside functions. So check this out. Number of function input arguments inside the body of a user-defined function. That's what we're doing. Nargin returns the number of input arguments that were used to call the function. So basically what that scalar allows us to do is check. So let's go ahead and do this. If nargin is not equal to 2, and we're going to produce an error. And the error that we're going to produce is must have 2 inputs to this function. So specifically what we're saying here is that if somebody tries to call this function but they don't have 2 inputs, we're going to produce an error term. Return means that the moment that we produce this error function, we're going to leave this function. So let's go ahead and do this. Let's pass 1 input to this function and see what happens. Error. Vector size input. You must have 2 inputs to this function. So it actually tells you the exact location of the error that was there. And that's kind of nice, right? So what we just saw was that first line here, we're doing our first kind of sanitizing in our function. We're trying to test 2 vectors to make sure they have the same number of entries. And the first thing that we do is we make sure that the person calling this actually does put in 2 vectors. We've just tested that that works, which is really nice. Why don't we go ahead and document what we've done here. Check that user passes 2 inputs into function. Okay, next thing that we might want to do, and it's working properly, right? If we passed X or Y, we could also pass like 3 inputs if we wanted to. Let's go ahead and push A, and we'll say that A is a rand I. Maybe we go to 20 and we say that it's a 10 by 4 or something like that, right? Let's try to pass 3 inputs. And notice that MATLAB again is getting angry. You have too many input arguments, right? All right, so the number of input arguments that we need, we've kind of tested that. Next thing we want to do is make sure that these are non-empty. So what we're going to do is kind of test if, well, let's see, is empty. What do we want to know? If X isn't empty or if Y is empty, we actually want to produce this statement that you must have the inputs to this function must be non-empty. Okay? Both inputs, or even better, at least one of your inputs is empty. Empty, that is no good. Which is no good. Okay, so here we go. Let's go back here, and we'll pass x and y, and again, y is an empty vector. We can see this. One thing that I might do every time is I'm going to go ahead and just clear memory and clear screen. This is a little bit precarious. This is in my testing phase, so I'm going to put this in here. I would not share this code with other people. I don't want to clear somebody else's memory if they're using my code, but this is a driver, which means I don't want to see this every time. Let's rerun this. Notice that we have an error. At least one of the inputs is empty, which is no good. So specifically, we know that both inputs should be non-empty. Let's go ahead and change that right now and make sure that it works. Okay, so far we've made sure that the number of arguments is 2. We have made sure that both of them are not empty. Next thing that we might want to do is to check that both are vectors. Remember that we're trying to make sure that two different vectors have the same number of entries. So we want to make sure that they're both vectors. So let's go ahead and do another if statement. So if x is not a vector, why don't we go ahead and use parentheses there? So we'll go ahead and say this one. Or y is not a vector. So if x is not a vector or y is not a vector, at least one input is not a vector. You know, we can be a little bit creative. Bad input, at least one input is not a vector. Right? We could do the same thing up there. Let's go ahead and test right now. So far we've kind of broken it in 3 different ways. Let's do this one as well. So x will be a matrix, y will be a vector. We expect this to produce the error, bad input, at least one input is not a vector. So specifically, we wanted to test 2 vectors for the same number of entries. Here, this makes sure that both is a vector. All right. So now we have all of our tests made up. So let's go ahead and code, document what we're doing. Checks to make checks that neither input is empty. And then this checks make sure that both inputs are vectors. We're now ready to run the heart of this code, and to do so we're going to do a little bit of thought here. I find that pencil and paper is really helpful here. In truth, I would never have started coding unless I had already done this, but because I'm trying to demonstrate kind of how I think about this problem, I'm going back and forth between thinking and coding. So here we have vector x, and we're going to say there's kind of 2 choices for vector x. It can either be a column vector or it could be a row vector, so column or row. In the case that it's column vector, we know that the number of columns times 1. In the case that it's a row vector, it's going to be the number of rows is 1, and then the number of columns will be not 1. So that is kind of one option that we have for the first vector, or the 2 different choices that we have is what I mean to say. And then of course we can say the same thing for the second vector. So vector y is either going to be what we call a column vector or a row vector. So let's think about each of those situations independently. If it's a column vector, we know that this is going to be the 1 column and certain number of rows. And in that case, this would hold independent of whether or not x is a column vector. And then in this situation, we've got mx times 1. But then if y is a row vector, we've got 1 row and whatever number of columns. And in this case, 1 row and whatever number of columns for both of those. All right, so remember that the goal of this function is to test whether or not these 2 vectors have the same number of entries. That would happen if we're in this thing, if x is a column vector and y is a column vector. The only way that those have the same number of entries is if those 2 things are true. So there's my condition in that situation. over here, we know that this is true if and only if my equals nx. Over here, mx must be equal to ny. And then over here, nx equal to ny. So this kind of gives me a hint at what my condition should be to test whether or not vector x has the same number of entries as vector y. One interesting thing about this, though, is that notice that if I'm going to use this condition, I have to think about this for a moment, it is not sufficient. It's not enough information just to check that mx is equal to my, because that's true over here as well, right? So these two could be different, and these could be the same. So specifically, I'm going to pose two conditions. Number of rows of x equals number of rows of y, and number of columns of x equals number of columns of y. And that actually will get me this one and this one, right? So this condition by itself will get me the case that both are column vectors and both are row vectors, and make sure that they're the same size. And then notice in this case, if I have nx equal my, I must also have that mx equal ny. So this dimension must equal that dimension. Over here, nx equals ny, I must also have that my equals nx. So I actually have three different conditions to check to make sure that these vectors x and y have the same number of entries, and those are my conditions. Okay, so if I'm going to use an if-elseif-else statement, I now have the different conditions that will tell me when the vectors have the same number of entries. So let's kick back to the coding. I'm going to save this paper on the side. I have this in my mind now. All right, so remember, we're trying to make sure that these two vectors have the same size, and we've just seen that there are going to be a few different cases. So if else, if else, and then end. All right, so let's do that first case first, that x is a column vector and y is a column vector. We'll use that logical short circuit and operator, so nx equal ny. So we should say both vectors are column or row vectors or maybe identical sized column or row vectors. Okay, remember the second case we had x was going to be a column vector and y was going to be a row vector. And then we just had to make sure that the other was true. So the number of columns of x equals the number of rows of y. And actually, I see right here that I actually don't need that third condition. I only have two conditions, right? If I go back to my notes on this, notice that this condition matches identically that condition. So I actually only need two different checks, right? That that the number of rows of y equals the number of columns of x, and the number of rows of x equals the number of columns of y. That's true in either of those situations, which means when I go back to this code, I actually don't need that particular situation. If either of those are true, we can set the output as true and then return. Remember that return will kick out of the function and return to the calling driver. So in this case, the driver is kind of determining what's happening. The moment that this evaluates to true, what this says is, please go back to the original script file that called this. So same thing over here. Once we have that, we'll return. If it's the case that neither of those things hold, we're going to call this false. So in that case, we would say that the inputs do not have the same size, and we're done. So we'll go ahead and return, and done. So let's go ahead and check. Let's pass a 10 by 4. We've already done that. We've already checked that matrices don't work. Let's do a 1 by 1 and a 10 by 1. Oh, and when I did this, of course, MATLAB is getting angry with me because I haven't yet gotten the dimensions. Let's do the dimensions right above. Let's do them here, actually. Mx, comma, nx equals size of x. And then we'll say this is going to be get the dimensions of input x. We'll go ahead and just copy and paste that. Here we're going to get the dimensions of input y. And we'll say this is my. And of course I got to change the input here to y. So now we have all of, we have the dimensions that we need, we have the tests that we need. Let's go back to the driver. We'll go ahead and run this now. So when we run, check that out. It is telling me my logical value is 0, so we're saying that it's false, meaning that the two vectors don't have the same size. Let's go ahead and say if we put a 10 there and a 1, let's run that one, that test works out, right? So we can actually label this, so same size vectors work. Let's test handling of empty arrays. So let's go back up. We're going to run a few different tests to make sure that we know what we're doing. So okay, at least one input is empty. So we know that in this situation, we get a false, or don't even get to run it. If we run that one, it works. Let's go ahead and switch. Let's say it's a 15 by 1 and a 15 by 1. It runs well. And then let's change the other one. Let's do 15 and 1. So that one works as well, right? It doesn't even produce input. And then we could do 14 by 14. And you know what we can do is let's go ahead and just test what happens if we put two of the same size matrices in. MATLAB gets upset because at least one input is not a vector, and that's bad input. So we now have a function that takes two inputs, makes sure that both are vectors, and then tests the question, do the vectors have the same number of entries? Notice that we don't care if they're row vectors or column vectors. We're just testing, does the number of entries in one match the number of entries in another? One of the takeaways of this I want to show you was that we used a driver script to test the various conditions and make sure that our function behaved the way that we wanted. This is a very classic mechanism for what we call debugging, and is a powerful programming tool. If you go back and watch this video a second time, or if you just think back to what we just did, I also want you to notice that every line of this function we developed step by step while checking it. So what we didn't do was write the entire function, cross our fingers, close our eyes, and push enter, and then pray that the output was what we wanted. Instead, each separate functionality in what we were doing, we coded up individually, tested it through the driver multiple times, and then by the time we get to the end of the function, we recognize that it runs the way it needs to because we've already tested it 15 times, meaning that when we're developing code, a great practice to use is to iterate the development and test each subblock of code individually. Thank you so much for your attention, y'all. Nice community challenge for today. Write a function that tests that your two inputs are matrices, and that the row dimension of the first input matches the column dimension of the second input. That's called conformable to matrix multiplication. We're going to use that in later lessons as we define our own matrix multiplication functions. So again, test that two matrices are conformable. The row dimension of matrix A matches the column dimension of matrix B. Write a function that does that. All right, y'all. I'll see you in the next video.